Bismillahirrahmanirrahim. Today the topic which we discussed will be the moment of force. First of all, what is meant by the moment of force? The moment of force is the tendency of the force which rotate the body about a given axis. Now this is the definition, and let's we go to the explanation that how the force produce the rotation of body. We have the body A. This body A is rotating in a circle, and this is the circle. The direction of motion is this, anti-clockwise, and this is the axis of rotation. First of all, what is meant by the axis of rotation? The axis of rotation is the perpendicular line to the point at which the force is applied. It's this is the point A. At the point A, the force is applied in this direction, and this will make the angle 90 degree. So this is the axis of rotation, and this axis of rotation will be equal to x and x bar. Now I apply the force. The force applied at point A will be in this direction into the board, like this marker. If this marker is the force, so this force applied on point A will be into the board, and it makes the angle of 90 degree with the axis of rotation. Now the distance between the point O, let's say this is the point O and this is the origin of the circle, and the distance between the point O and the point A will be equal to the radius of the circle. We represent the radius of the circle with R. Now its mathematical form will be equal to first of all we represent the moment of force with the alphabet M, and this M will be equal to the force and the perpendicular distance between the force the point of force and the axis of rotation. So this will be equal to R multiplied by F. R multiplied by F. This is the F. So the moment of force will be equal to the cross product of R and F. Now, if we simplify it, then it will be equal to M is equal to R F sine theta. This theta is the angle between the force and the moment arm. This is the moment arm. The R is the moment arm. So, and the moment I already discussed that the moment arm is the perpendicular to the axis of rotation, and it is the perpendicular distance of OA. Here the OA is the moment arm. So this theta, first of all, what is meant by this theta? This theta is the angle between the force and the moment arm, and here the angle will be equal to 90 degree. So if you put this 90 degree in this equation, then it will be simplified into F is equal to R F sine 90. So as we know that sine 90 is equal to 1. So put in this equation, it will be equal to M is equal to R F. So the moment of force for this force acting at point A will be equal to the product of moment arm and the force. So this equation will give us a moment of force. Now if the force is applied at some angle, then how we find the moment of force? So we go toward we represent the second case in which the force is applied at some angle. Then how we find the moment of force? So this is the routes for the body A in which the body is revolving. Let's say the body is represented by A point. So if the force, let's say the force F is applied at some angle. This is the axis of rotation, and this is the point 0. So we know that the moment of force is equal to the force multiplied by moment arm, and moment arm is the perpendicular distance from the point at which the force is applied to the axis of rotation. Here the distance between OA is not perpendicular. So how we find the perpendicular distance? So let's say this is equal to the radius r. For that we resolve the force. We extend the force further. This is the force. So the perpendicular distance will be equal to this. This point, we represent this point by point C. So the moment of force for this type of figure will be equal to the force multiplied by perpendicular distance, and the perpendicular distance is OC. So the moment of force for this figure will be equal to F multiplied by OC. So now we are interested in OC, and how we find the OC, as we know that this is, for example, let's say this make the angle theta, and we know that the sine theta is equal to OC divided by OA. Here you know that the OA distance is equal to the R. So putting the value in this equation, it will be equal to sine theta is equal to OC divided by R, and the OC will be equal to sine theta multiplied by R. So now putting the value of OC in this equation, so it will be equal to the moment of force with F R sine theta. So this is the final equation for finding the moment of force, and that moment of force for this figure will be equal to the magnitude of force and the magnitude of the distance between OA distance and the theta which the force making with the OA line. So this will give us the moment of force. Now the unit for the moment of force or the torque will be equal to Newton meter. Newton is the unit of force, while the meter is the unit of R, or it will be equal to kilogram meter square per second square. The direction for the moment of force is in this direction. This is the sign for the representing the moment of force, and we always take the anti-clockwise moment of force positive, while the clockwise will be equal to the negative.